The next rule is chain rule. If y equals fu is a differentiable function of u, and u equals gx is a differentiable function of x, then y equals f of gx is a differentiable function of x. And the chain rule can be written as dy dx equals dy du times du dx. Now, we go to example number 10 on page 9. Given y in terms of u and u in terms of x. So, to find dy dx, first we need to find dy du. dy du equals 3u squared minus 6u. And du dx equals 2x. We know that the chain rule is dy dx equals dy over something and something over dx. For this case, we are using u. So here will be du and this is also du. Next, we substitute the functions. So we will get dy du is 3u squared minus 6u and times du dx is 2x. And next, we need to substitute u in terms of x. So we have 3 times x squared plus 2 squared minus 6 times x squared plus 2 and then times 2x. Okay, next, we have x squared plus 2 and this is also x squared plus 2. So we can factorize x squared plus 2 power of 1. Okay, inside the bracket we have 3 times x squared plus 2 and minus 6 times 2x. Then we have x squared plus 2 times 3x squared and times 2x. And the final answer will be 6x power of 5 plus 12x cubed. Okay, we have done example number 10. Okay, the next one is about power rule. For the power rule, let's say we have y equals u power of n. So, dy du equals, we write down n. So, we have n and then u power of n minus 1. We reduce the power by 1. And du dx equals f prime x. And as previous, this is the formula for chain rule. Dy dx equals n u to the power of n minus 1 times f prime x. Thus, we have differentiation of f of x power of n equals n from the original power. Copy the function and reduce the power by 1. And we multiply by the derivative of the function itself. Okay. So we go to example 12 on page 10. Differentiate with respect to x using general power rule. For part A, we have fx equals x power of 5 plus 1. So now, f prime x equals, okay, bring down the power. So we have 3 times, copy the inner function, x power of 5 plus 1. Reduce the power by 1, so we have power of 2. And next, we need to differentiate the inner function, which is x power of 5 plus 1. So we have 3 times x power of 5 plus 1 squared times 5x power of 4. So we have 15 x power of 4 times x power of 5 plus 1 square. So this is the answer for part A. Okay, next, we go to higher order derivative. For first derivative, we have y prime or f prime or dy dx. For second order, we have double prime or f double prime or d squared y over dx squared. Third order, we have y triple prime, f triple prime, and so on. Example number 13, page 11. Find the first, second, and third order derivative. So p prime x, the first order will be negative 8x power of 3 plus 27 x squared minus 10x. For p double prime, the second order, we differentiate one more time. So we have negative 24x squared plus 54x minus 10. And for the third order, we have negative 48x plus 54.